Hello everyone, I am Anuradha Sharma. I am your maths mentor. Today, in this session, we are going to learn continuity and differentiability. The weightage of this chapter in ISC board exam is 4 marks. If you don't know exact definition of continuity, I would recall the dictionary meaning of word continuity. You would be able to understand that which out of these four graphs which is actually continuous. As illustrated by all these, the first one, it was running quite smooth until it had this loop in the middle. Second one graph. In second one is completely disjoint because it has break or jump at axis A. So that's why this is a discontinuous function at the point A. Look the third one graph. In the third one, the graph, it is approaching towards the infinity nearer axis A. So that's why this is a discontinuous function. Look fourth one. In fourth one graph, it happens to be only smooth curve without lifting the pen. So that's why it is a continuous function at x is a. To build upon an idea, the graph has no jump and no break in between. So we can say function is a continuous function at the point A. In short, any curve which you can make without lifting your pen becomes continuous function. Now let us try to dig deep into these graphs and come up exact definition of continuity. If you see the first one graph, you recollect 11th class chapter limit, then you realize this is point A, where the limit exists, but it does not equal to the FA. Limit is exists, it means left hand limit is equal to the right hand limit. Limit is exists and left hand limit is equal to the right hand limit, but it doesn't equal to the FA. So look it in the second graph. If you look in second graph, then you can easily look at it has break or jump at the point A and limit does not exist. So that's why we can say the function is a discontinuous function at the point A. And if you look the third graph, in the third graph, limit does not exist because it is approaches towards the infinity nearer the point A and limit does not exist, it means left hand limit is not equal to the right hand limit and the graph doesn't meet at the point A. So that's why we can say FA is not defined. So this is not a continuous function. Now, if you look the fourth graph, in fourth one graph, without lifting the pen, then it may. So that's why it is a continuous function. And in this graph, we can say left hand limit is equal to the right hand limit and this is equal to the FA. So now we can give the actual definition of the continuity. In the continuity, fx is said to be a continuous function at x is equal to the a if limit x tends to the a minus fx is equal to the limit x tends to the a plus fx is equal to the fa. So we can say the function is a continuous function at x is equal to the a. Limit x tends to the a minus fx, it means left hand limit. So, and limit x tends to the a plus fx, it means right hand limit. In the left hand limit, we have to put the x is equal to the a minus h. And in right hand limit, we have to put x is equal to the a plus h. So if you are putting the x is a minus h in the left hand limit, so we can write limit h tends to the 0 f a minus h. And then if you are putting the x is a plus h in right hand limit, so we can write limit h tends to the 0 f a plus h. Limit x tends to the a minus, it means it is the slightly less than the point A, and x tends to the a plus, it means it is the slightly more than a. So that's why left hand limit is equal to the right hand limit and it is equal to the fa. So we can say function is a continuous function at the point A because limit h tends to the 0 f a minus h is equal to the limit h tends to the 0 f a plus h is also equal to the f a. That's why function is a continuous function at the point A. Now we should be understand the concept of x tends to the a minus. So by x tends to the a minus, we can say that it approaches a from the left on replacing x by a minus h. We observe that x approaches a from the left if h approaches 0. By x tends to the a plus, we mean that we mean that it x approaches a from the right on replacing x by a plus h. We observe that x approaches a from the right if h approaches to the 0. So now we know the meaning of the x approaches to the a minus and x approaches to the a plus. Once again I am repeating this. X approaches to the a minus, it means slightly less than a. It means it is towards the left side. And x approaches to the a plus, it means slightly more than. It means it is approaches from the right side. So that's why if both are equal and it is also equal to the fa, then we can say function is a continuous function at a. So now we can easily solve the question based on it. So we will carry this definition forward and see how to tackle the questions. So look at this question. In this question, it is given. Examine the continuity of the function fx is equal to 2x square minus 1 at x is equal to the 3. So first of all, we have to look the value of the function. Value of the function, it is given 2x square minus 1. So find the value at x is equal to the 3. Find the value of the function at x is equal to the 3. So if you substitute the x is 3, so you will get 2 multiplied with the 3 square minus 1, and after simplifying it you will get the result is 17. So value of the function at the point 3 is equal to the 17. Now we can easily find the right hand limit. Right hand limit, we have to apply the formula. Limit x tends to the 3 plus fx. After applying it, then you have to substitute the value of the function. The value of the function is 2x square minus 1. And then write limit x tends to the 3 plus 2x square minus 1. 3 plus it means then it is approaches to the right. So that's why we have to write the value of the x is equal to the 3 plus h. Substitute the x is 3 plus h. Then we get limit h tends to the 0 to multiply 3 plus h whole square minus 1. And then simplify it. Then you will get this is equal to the 17. So right hand limit is equal to the 17. Similarly, we can solve the left hand limit. In the left hand limit, we have to apply the definitions. So it is limit x tends to the 3 minus fx. 3 minus it means we have to find the left hand limit at the point x is equal to the 3. So put the value of the function. Value of the function is 2x square minus 1. So we can write limit x tends to the 3 minus 2x square minus 1. Now, after writing it, 3 minus, it means it is approaches to the left. So it means put the x is 3 minus h. So replace the x by 3 minus h. Then we get limit h tends to the 0. 2 into 3 minus h whole square minus 1. And after simplifying it, then we get the result is 17. So left hand limit is 17 and right hand limit is 17 and value of the function at the point 3 is also 17. So in all the cases we get the result is 17. So therefore we can say limit x tends to the 3 plus fx is equal to the limit x tends to the 3 minus fx is equal to the f3. It means right hand limit is equal to the left hand limit and this is equal to the f3. So function is continuous at x is equal to the 3. Now we can look at this. A function fx may fail to be continuous at x is equal to the a by the following reasons. Now look at the first point. In the first point, f is not defined at x is equal to the a. It means function is not defined at the particular point a. So we can say function does not exist and it will not be a continuous function. In the second point, either limit x tends to the a minus fx does not exist or limit x tends to the a plus fx does not exist. It means left hand limit value it may be infinite and right hand value may be infinite. If the any one is not exist, so we can say function is not a continuous function at the point A. Look at the third point. In the third point, then if limit x tends to the a minus fx is not equal to the limit x tends to the a plus fx, so again we can say function is not continuous at x is equal to the a. But in this limit x tends to the a minus fx is has it has certain value and limit x tends to the a plus fx it also has the certain value and both the values are not equal. It means both the values are not same. So that's why left hand limit is not equal to the right hand limit. And if both the limits are not equal to each other, so again function is a discontinuous function at x is a. Look at the fourth point. In the fourth point, if the limit is exists and it means left hand limit is equal to the right hand limit, but it does not equal to the fa. If it is not equal to the fa, so then function is not a continuous function at the a. So we can also say that then f is said to have removable discontinuity at x is equal to the a. For the removable discontinuity, we have to write the left hand limit is equal to the right hand limit, but it doesn't equal to the FA. If the limit is exists, but its value is not equal to the value of the function at the point A, so that's why we can say it has removable discontinuity at x is equal to the A. So for the removable discontinuity, we can easily understand by this example. Look this example. Show that the function fx is equal to the x sine 1 upon x if x is not equal to the 0. Otherwise, the value of the function is equal to the 1 if x is equal to the 0. Has removable discontinuity at x is equal to the 0. So now we have to look at the function is continuous or not at the point x is 0. So in this we have to prove then function has removable discontinuity at the x is equal to the 0. So it means function should not be continuous at the point is 0. So first of all, put the value of the x is equal to the 0. If you are putting the value x is 0 in the given function, so you can easily locate if x is equal to the 0, then value of the function is becomes 1. So that's why we can write f0 is equal to the 1. Afterwards, we have to find the right hand limit and the left hand limit. Now we get f0 is equal to the 1 and look at then how to find the left hand limit. In the left hand limit, we have to apply the formula limit x tends to the 0 minus fx. And now substitute the value of the fx. We get limit x tends to the 0 minus x into sine 1 upon x. And then after writing it, because it is shows the left hand limit, so 0 minus it shows the left hand limit. So we have to replace the x by 0 minus h and then substitute x is 0 minus h, and afterwards we get limit h tends to the 0, 0 minus h sine 1 upon 0 minus h. Simplify it, we get limit h tends to the 0, h sine 1 upon h. You know very well, then the value of the sine theta, it is more than or equal to the minus 1, but always less than or equal to the 1. So that's why we can say sine 1 upon h shows the certain value. It should be lies in between minus 1 and 1. So h multiplied with the certain value of sine theta. So after applying the value of the limit, we get 0 into certain number lies in between minus 1 to 1, and then their product is because the 0. So that's why the value of the left hand limit is equal to the 0. Now we need to find the right hand limit. So in right hand limit we can write limit x tends to the 0 plus fx and substitute the value of the given function, and after writing it we have to put the x is equal to the 0 plus h. You replace the x by 0 plus h, then we get limit h tends to the 0, 0 plus h sine 1 upon 0 plus h. Limit h tends to the 0, h sine 1 upon h is equal to 0. So again you have to apply the same concept whatever we have already applied in the left hand limit. In the left hand limit we say that sine theta is always more than or equal to the minus 1 but less than or equal to the 1. So after applying this concept in the right hand limit, we get the value of the right hand limit is equal to the 0. Now we have limit, right hand limit is 0, left hand limit is 0. So both are equal. It means limit is exists. But these two values are not equal to the f0 value because f0 is given to the 1. So that's why we can write this step. Limit x tends to the 0 plus fx is equal to the limit x tends to the 0 minus fx. but it doesn't equal to the f0. So if it is not equal to the f0, so that's why function has the removable discontinuity at x is equal to the 0. So we know the definition of the removable discontinuity. It means left hand limit is equal to the right hand limit, but it doesn't equal to the fa. And same thing we can look at in this example also. Limit x tends to the 0 is plus fx is equal to the limit x tends to the 0 minus fx, but it does not equal to the f0. So function has removable discontinuity at x is equal to the 0. Now we can look at this example. Show that the function 2x minus modulus of the x is continuous at x is equal to the 0. Before starting the solution of this question, first of all, we should be know about the modulus of the x. So the definition of the modulus of the x is equal to the minus x when x is less than 0, and it is equal to the x when x is more than or equal to the 0. If we apply this concept in the given function, so we can easily get the value of the function when x is more than 0 and when x is less than the 0. If you are writing the x is more than the 0, so value of the mod of x is equal to the x. It means it shows the positive value. And then you are writing in the given function 2x minus mod of x. Mod x is the positive value of the x. So we get 2x minus x. Simplify this 2x minus x, then we get this is equal to the x. So we can say the value of the function fx is equal to the x when x is more than or equal to the 0. And look it in the modulus case, mod of x is equal to the minus x when x is less than the 0. If we applied this in the given function, so we get 2x minus x. Minus multiply with the minus sign, we get the plus. So the result becomes 2x plus x, and 2x plus x is equal to the 3x when x is less than the 0. So now we get the value of the function. Value of the function fx is x when x is more than or equal to the 0, and value of the function fx is equal to the 3x when x is less than the 0. Now we have to solve this question. Look at the left hand limit at the point x is equal to the 0. Apply the formula. Limit x tends to the 0 minus fx. The fx value you have to write. 0 minus you know very well. It is slightly less than the 0. It means the value of the x should be less than 0. So look at the value in the given function. When x is less than the 0, the value of the function is becomes 3x. So substitute here 3x. After writing it, we have to replace the x by the 0 minus h. So replace here and then simplify it and apply the limit value. Then result becomes the 0. So we can say left hand limit is equal to the right hand limit. Left hand limit is equal to the 0. Now we need to find the value of the right hand limit. Right hand limit at x is equal to the 0. Again apply the definition of the right hand limit. Limit x tends to the 0 plus fx, and now we have to put the value of the fx. So value of the fx, because it is showing the 0 plus, it means slightly more than, so it means the value of the x should be more than 0. So the value of the fx is becomes the x when x is more than or equal to the 0. So write the value of the function in the right hand limit. So we get limit x tends to the 0 plus fx. After writing it, we have to substitute the value of the x is becomes x is equal to the 0 plus h, because it is given in the right hand limit. Right hand limit, it means it is approaches to the 0 to from the right side. So that's why we have to write 0 plus h. Substitute the value of the limit, then we get the result is 0 in right hand limit. So now we get the value of the left hand limit and right hand limit. Now we need to find the value of the function at the point is 0. So we can easily look at then f0 is equal to the 0, and because the value of the function of it is equal to the x when x is more than or equal to the 0. If you are putting the value of the x is 0, so that's why we get the value of the function is becomes the 0. So we can write f0 is equal to the 0. After getting it, then we can write left hand limit is equal to the right hand limit, but it is also equal to the f0. Therefore, function is a continuous function at x is equal to the 0. Now, we can look at this also. Continuity of a function on an interval. Now, we have to study about the different intervals. So, we have to look at the continuous function on open interval and continuous function on closed interval. And in next point, we have to look at the everywhere the function is a continuous function or not. So first of all, we have to look the continuity function on open interval. In the open interval, then we have to consider that function f is said to be a continuous function on open interval AB if f is continuous at every point of AB. That is, if we consider the C point, it is belongs to the open interval AB. So if function is continuous, so that point should at the point C, then it should be show the continuity. If it is showing the continuity at the point C, so we have to write limit x tends to the C minus fx. This is equal to the limit x tends to the C plus fx, and it is equal to the fc. So if it is showing it, so that's why we can say function is a continuous function on an open interval. Same thing we have already applied in the questions, then you have already seen in the previous slides. Now look at this in the graph. Then if you are looking the point at the point A and the point AB. If I am talking about the open interval, so in between the interval A and B, then function it is showing the continuity, and then it without lifting the band it has made. So that's why we can say that it is a continuous graph in open interval, because open interval it means except the point A and B we can consider the any other point in between the A and B. If you take the any point in between A and B, then it shows the continuity because it made without lifting the pen. So that's why function is continuous on open interval. Look at about the continuity on closed interval. If you are looking here, so you have to follow this point. First of all, listen in. A function f is said to be a continuous function on a closed interval. Closed interval we have to define by the square bracket. If in this, we have to follow these points. First point, f is continuous at every point of the open interval AB. So I have already explained this. Then you know very well what is the meaning of the open interval. Now look at the second point. F is a right continuous function at x is equal to the a. Right continuous, it means it should be the slightly more than the a. Slightly more than the a, it means we have to write limit x tends to the a plus fx, and continuity, it means that this value should be equal to the fa. Now look at the third point. In the third point we can write f is a left continuous at x is equal to the b. It means we can write limit x tends to the b minus fx is equal to the fb. So how to apply in the graph? So you can easily look it in the graph. So it is the same as the previous one graph. So if you look the nearest point A and nearest the point B, then nearest the point A, then you can easily look at the graph. It is not showing in the left hand side, but it is the in the right hand side. So that's why if you if you want to find the continuity at the point A, so we can say if the graph is towards the right side and it is the slightly more than the A, then it will should be the continuous at the point A if it is equal to the FA. So that's why we can say limit x tends to the A plus fx is equal to the FA near the point A. Similarly, if I am talking about the point B, so you can easily look at there, then after the point B, graph is not here. So that's why we cannot be take the right hand limit, but we can take the left hand limit because graph is given in the left hand side. So if it is approaches to the B, so it means slightly less than the B. The value of the slightly less than the B, it should be equal to the FB. So that's why we can say function is a left continuous at the point B. So we can write limit x tends to the b minus fx is equal to the fb. And now if you look the first point, in the first point it is given, then the function should be continuous in open interval ab. So in between the a and b, you can easily locate this whole graph is made without lifting the pen. So that's why function is continuous on open interval AB. So now then we can conclude that if all the points are follows by the given function, so that's why function is a continuous function on closed interval AB. So that's why we have to look at the all the 3 points in the in the closed interval. Now look at the third point, everywhere continuous function. In this, we can say a function f is said to be continuous everywhere if f is continuous at every point of the real line. Real line, it means I am talking about the all the real numbers. If function is a continuous everywhere, it means it is a continuous at every point of the real numbers. Now, we can easily understand by the question number 2C part. So look at here, the function value it is given x square minus 25 upon x plus 5 when x is not equal to the minus 5. So here the point is not given where we have to prove the continuity, whether the function is the continuous or not. So we have to consider the a point our cell, and then we can write let a be any real number. Now we have to check the continuity at the point a. So first of all, find the left hand limit. In the left hand limit, you can write limit x tends to the a minus, and value of the function is x square minus 25 upon x plus 5. After writing this step, then we have to put the value of the x is a minus h. So we can write limit x tends to the a minus is a minus h whole square at the end upon a minus h plus 5, and otherwise we maybe simplify the function like this because it is given x square minus 25. So x square minus 25, if we make the factors, so we can apply the formula a square minus b square. A square minus b square is because the a plus b is into a minus b. applied here, and then afterwards we can cancel the x plus 5, and afterwards we get limit x tends to the a minus x minus 5. Now we can apply the value of the x, so we get limit x tends to the h tends to the 0, x value replaced by the a minus h, so we get a minus h minus 5, and afterwards we have to put the value of the limit, so we get this is equal to the a minus 5. Now left hand limit is equal to the a minus 5. Now look at the right hand limit. For the right hand limit we have to apply the formula limit x tends to the a plus of the fx. The value of the function is the x plus 5 into x minus 5 upon x plus 5. So x plus 5 is cancelled. So that's why we get limit x tends to the a plus x minus 5. And afterwards we have to replace the x by the a plus h. So we can write limit h tends to the 0 a plus h minus 5. And then if you are putting the value of the h is 0, so we can write this is also equal to the a minus 5. Left hand limit value is also a minus 5. Right hand limit value is also a minus 5. So we can say left hand limit is equal to the right hand limit. And now we need to find the value of the function at the point A. This is also equal to the a minus 5. So all the result, it means I am talking about the left hand limit and the right hand limit and the value of the function at the point A. All the in all the things it is equal to the a minus 5. So that's why we can say then the function is a continuous function at the point A. So we can write this step left hand limit is equal to the right hand limit. It is equal to the fa, and value of in each the term we get this is equal to the a minus 5. So that's why we can say function is a continuous function in all the points. Now we have to look these operations also. If the f and g both are the continuous function, and if we are adding these two functions, so this is also the continuous function. Sum of two continuous function is a continuous function. If you are saying, if I am saying f and g both are the continuous function and their difference is also a continuous function, so we can write f minus g is continuous at point C. It means we can say difference of the continuous function is a continuous function at the point C. If we do continuous function multiplied together, so we can write f into g. It means fg is a continuous at C. So product of the two continuous function is a continuous function. If I am talking about the quotient rule, it means f upon g. F and g both are the continuous function at the point C. So we can say f upon g is also a continuous function at the point C when at g at the particular point C is not equal to the 0. So quotient of the two continuous function is a continuous function. Sometimes in the question we maybe apply this concept also. Now look at this exercise 7 in question number 10. In question number 10, it is given fx is equal to the x cos 1 upon x when x is not equal to the 0. Fx is also equal to the 0 when x is equal to the 0. So, first of all, we need to find the left hand limit. Left hand limit is limit x tends to the 0 minus fx. Put the value of the function. Value of the function it is given x cos 1 upon x, and after writing it you have to replace the x by the 0 minus h. Then we get limit h tends to the 0, 0 minus h cos 1 upon 0 minus h. Then afterwards we get the limit h tends to the 0 minus h cos 1 upon minus h. And then we get limit h tends to the 0 minus h cos 1 upon h, because cos minus theta is equal to the cos theta. So if we applied here, so cos minus theta is becomes the cos theta. So we can write limit h tends to the 0 minus h cos 1 upon h. After writing it, then we can say then minus h multiply with this cos 1 upon h. It means if you are putting the value of the limit, so value of the limit is becomes the 0. 0 multiply with the certain value lying in between minus 1 and 1. It means I am saying the value of the cos theta, it means value of the cos 1 upon h lies in between minus 1 and 1, because cos theta is always more than or equal to the minus 1, but it is less than or equal to the 1. So that's why we have to apply this concept here to get the result of the limit. So value of the limit is equal to the 0. After getting it, we need to find the right hand limit. So right hand limit we can write limit x tends to the a plus x cos 1 upon x, and then you have to write it limit h tends to the 0 and x replaced by the 0 plus h. So after writing it 0 plus h cos 1 upon 0 h, we can write this is the h cos 1 upon h. And now we can say if we are putting the value of the limit and then simplifying this, so we get this is equal to the 0 into certain values lie in between minus 1 and 1, because cos 1 upon h is lies in between the minus 1 to 1. So that's why if we apply the same concept, whatever we have already applied in the left hand limit, so we get the result is equal to the 0. After getting it, then we can say left hand limit is equal to the right hand limit. And now we need to find the value of the function at the point x is 0. If we look at this question, so we can look at the fx is equal to the 0 when x is equal to the 0. So that's why we can write f0 is equal to the 0. After writing it, we can write this step left hand limit is equal to the right hand limit. This is also equal to the f0, because in all the left hand limit and right hand limit and f0 we get the value of the this value is equal to the 0. So that's why we can say function is a continuous function at x is equal to the 0. So this is the way to simplify the question. And now you look at this when the function has different value on both the sides of the given points. This is we have to discuss the continuity of the function fx at x is equal to the 1 upon 2 when fx is defined as follows. Fx is equal to the 1 by 2 plus x when x is more than or equal to the 0 but less than the half, and fx is equal to the 1 when x is equal to the half, and the value of the function is equal to the 3 by 2 plus x when x is more than half but it is less than the 1. So in this already mentioned, when the function has the different value, then you can easily look at in this question, function has different value on both the side of the given point. It means point is given the 1 upon 2. So if I am talking about the lesser than the half, so it means the value of the function is becomes 1 upon 2 plus x. If I am talking about the more than half, if the x is more than the half, so value of the function becomes the 3 by 2 plus x. And if it is equal to the half, so the value of the function it becomes the 1. So that's why how to tackle these type of the questions. Look at here in this. First of all, find the left hand limit at the point x is equal to the 1 upon 2. So apply the formula limit x tends to the half minus fx. Now we have to substitute the value of the function, and half minus it means it should be less than the half. So that's why if it is less than the half, the value of the function is becomes 1 upon 2 plus x, because it is already given when x is more than or equal to the 0 but less than the half. Function value is less than the half. So at this point it is showing fx is equal to 1 upon 2 plus x. So substitute this value in the given function. So we get limit x tends to the half minus, and then replace the fx by 1 upon 2 plus x. After writing this step, 1 upon 2 minus, it means we have to replace the x by 1 upon 2 minus h. Then if you are writing here, so we can write limit x tends to the half, it becomes the limit h tends to the 0, and then replace the x by the half minus h. We get this is equal to the 1 upon 2 plus 1 upon 2 minus h. Substitute the value of the limit, and then afterwards we get 1 upon 2 plus 1 upon 2. This is equal to the 1. So now we get the value, left hand limit value is 1. Now we need to find the right hand limit. So in the right hand limit, we have to apply this formula. Limit x tends to the 1 upon 2 plus and fx. So now we have to look at the function value if it is the slightly more than the half. If x value is more than the half, so we can write the 3 upon 2 plus x already given in the question. So now replace the fx by this. We get 3 by 2 plus x. After writing it, then we have to look at this is the right hand limit, and it is given it is approaches to the half, plus it means it is slightly more than. So that's why we have to replace the x by the 1 upon 2 plus h. And then if we replace this by the 1 upon 2 plus h, then we get limit h tends to the 0, 3 by 2 plus 1 upon 2 plus h. Now substitute the value of the limit. So we get 3 by 2 plus 1 by 2 is because the 4 by 2, and the after simplifying we get the result is 2. So that's why we can say the value of the right hand limit is equal to the 2. Now we need to find the value of the function at the point half. So value of the function at x is equal to the half. So in this, it is already given in the question, it is equal to the 1. So we can say the value of the function at the point x is half is equal to the 1. After writing it, then we have to look at whether the limit, whether the function is continuous function at the point x is half or not. So we can easily look at then f function value at the x is equal to the half is 1, and left hand limit is equal to the 1, and right hand limit is equal to the 2. Therefore, we can say right the function is discontinuous function at x is equal to the half. Now we can look at the another one thing. If the given that the function is continuous at x is equal to a, then find the unknown value. This type of the question is very important, and then it may become in the board exams. So you have to try to solve these type of the questions. So look at this example 16. For what the value of the lambda is the function when function value is given lambda into x square minus 2x if x is less than or equal to the 0, and it is equal to the 4x plus 1 if x is more than the 0. So now we have to find the continuous at x is equal to the 0. If it is already continuous at x is equal to the 0, we need to find the value of the lambda. And what about the continuity at x is equal to the 1? First of all, we need to write the if the function is continuous at x is 0, So we can say left hand limit is equal to the right hand limit, and it is equal to the f0. Afterwards, you write left hand limit value, limit extends to the 0 minus fx, and it means this is equal to the right hand limit. Right hand limit value is the limit extends to the 0 plus fx. This is equal to the f0. If we are writing the limit extends to the 0 minus fx, so it means we can write this is equal to the limit extends to the 0 minus lambda into x square minus 2x. So now we have to write the right hand limit value. At the right hand limit, the value of the function is becomes 4x plus 1. So right here, and this is equal to the f0. Value of the f0, it is already given, it is as a 0, and we can say the in the left hand side, this is the substitute the x is 0 minus h, and then if we simplifying it, we get the lambda multiplied with the 0, result becomes the 0. So left hand side is the 0. Similarly, we can solve the right hand limit also. In the right hand limit also, we can write limit s tends to the 0, 4 multiplied 0 plus h plus 1, because x is replaced by the 0 plus h. After simplifying it, then again we get the result is becomes the 1. So in left hand side we get 0 and right hand side is the 1, and f0 is also equal to the 0. Function is discontinuous at x is equal to the 0. So that's why now lambda is multiplied with the 0 value. So we can say it is a discontinuous. Lambda may have any value, and now we can write the function is a discontinuous because left hand limit is not equal to the right hand limit, and then we can say then x it maybe have the any value of the lambda, and now we have to find the continuity of the same function at x is equal to the 1. So for examining, first of all we need to find the value of f1. So replace the x by the 1, we get the 4x plus 1, and this is equal to the 5. After writing it, find the right hand limit. Right hand limit is equal to the limit x tends to the 1 plus fx, and value of the function is becomes the 4x plus 1. And now you have to replace this 1 plus h, and afterwards we get the value of the right hand limit. After getting it, look at the left hand limit. In the left hand limit, we get limit x tends to the 1 minus fx is equal to the limit x tends to the 1 minus 4x plus 1, and then you replace the x by 1 minus h, and after replacing it, if you simplify it and then putting the value of the limit, then you will get the result is 5. So we can easily observe it. Left hand limit is also 5 and the right hand limit is also 5, and then the value of the f1 is also the 5. So in all the cases we are getting the result is 5. So that's why we can say function is a continuous at x is equal to the 1 for every real value of the lambda. So the value of the lambda, it may be different. It does not give any effect to the value of the limit at the point x is equal to the 1. Now look at about the differentiability. After completing this continuities portion, now we have to study about the differentiability. In the differentiability, there is a point C in this domain. It means I am talking about the differentiability. We can say let f be a real function. There is a point C in its domain. Real function, it means then domain and range both are representing the real number. So f is a function from R to R, and it should be in the particular domain. So that's why we can say function is a differentiable if it is follows that f dash c is equal to the limit x tends to the c fx minus fc upon x minus c. After writing it, then we can say, then it means limit extends to the c. Only c is written here. It means then limit is already exists. So it means left hand limit is equal to the right hand limit. And then for the differentiability for this function, we can write left hand differentiable. Left hand differentiable, it is represented by the LF dash x. So it means then you have to write limit x tends to the c minus, and then again you have to put the value of the f dash x. This is fx minus fc upon x minus c. So replace the x by the c minus h. Then we get limit h tends to the 0 f c minus h minus fc upon c minus h minus c. Because here it is given the limit x tends to the c minus, it means slightly less than the point c. If it is slightly less than, that's why we have to replace the x by the c minus h. After simplifying it, we get limit h tends to the 0 function of the c minus h minus f of the c. This is divided by the minus h because c is cancelled by the minus c. So that's why we get the denominator value is equal to the minus h. Whenever we have to apply, we have to solve the question. So we have to write left hand differentiability is equal to the limit h tends to the 0 f of c minus h minus f of the c, this divided by the minus h. Afterwards, look at the right hand differentiability. Right hand differentiability, because I have already told you limit is exists, so we have to write by this way. R f dash x, it is represented the right hand differentiability. This is equal to the limit x tends to the c plus fx minus fc upon x minus c. After writing it, then you have to replace the x by the c plus h, because c plus it is given, it means slightly more than the c. So if it is slightly more than the c, so we can say should be equal, this should be replaced by the c plus h. So that's why we can write limit h tends to the 0 fc plus h minus fc upon c plus h minus c. After writing it, we can say limit h tends to the 0 fc plus h minus fc upon h. And then we can say the left hand limit is equal to the left hand differentiability is equal to the right hand differentiability. So then it means it hold the differentiability. But before understanding it, before we should be know about the meaning of the differentiability. So this can be easily understood by the given graph. So if you look this graph, in this graph it is given a curve, and then if you draw a line, then it will be cut the intersect the graph at a different point. First point I marked as a, second is B, and the third one I have considered as the B point. Middle one is the P. And if you draw the perpendicular line from the point A to the x-axis, then from the point B to the x-axis, and from the point B to the x-axis. And similarly, we can draw the perpendicular line through the point A to the y-axis and through the point P to the y-axis. And if we draw the perpendicular through the point B to the y-axis, so we can easily draw it. After drawing it, we can mark the value fc plus h at the y-axis after putting the value in the given function fx. And if x is equal to the c plus h, if the value of the x is the c, then we can say the value of the function is becomes the fc. If the value of the x is c minus h, then the function becomes the fc minus h at the point A. After drawing it, then we can easily locate these points, and then it is approaches to the, if the point A is approaches to the P, so then function fc minus h, it is the nearest to the fc, and C minus H, it is nearest to the point C. So that's why H is becomes to the 0. If H is becomes to the 0, so that's why we can say the function value is it becomes the FC. And similarly, if you look the point P, and the point P is approaches to the point P, it means it is the very closer to the point P. So we can say the value of the X is C plus H at the point B. But if it is closer to the point B, it is moving towards the point B. So it is the C plus H is becomes as is C. So again we can say limit H tends to the 0 because it is approaches to the C. Now at this point we can say the value of the function fc plus h is becomes the fc. After this we can say then it becomes the tangent at this line is becomes the tangent at the point P. So if you are finding the slope of the chord AP, so you know very well the formula of the code for finding the slope. This is equal to the y2 minus y1 upon x2 minus x1. So y2 minus y1, if you are taking these 2 points A and B, so you have to consider only these value. At the y-axis, it is given the fc and fc minus h. So we can write in the numerator. So we can write this is the fc minus h minus fc. Fc minus h, if I am talking about the Fc minus h, so this at the point A, the value of the x is becomes the C minus h. So that's why you have to write here C minus h. And then point B, it is the C. So that's why we have to write here the minus C. So limit h tends to the 0, limit h tends to the 0, fc minus h minus fc upon c minus h minus h. After writing it, then we have to find the slope of the chord BP, and then we can easily get it. Now, if you are finding the slope of the chord BP, so you have to write the slope of the chord BP is equal to the limit h tends to the 0 fc plus h minus fc upon c plus h minus h, because the point B is approaches to the P point. So it means c plus h is becomes as a c, and it is approaches towards the C. So that's why we can write limit h tends to the 0. And after writing it, then we can write limit h tends to the 0 fc plus h minus fc upon h, because in denominator c and minus c will be cancelled to each other. So that's why the denominator becomes the h. After writing it, if the point A and point B, I have already told you, it is approaches to the P point. So it means it is very closer to the point P. So that's why we can say the slope of the chord AP is equal to the slope of the chord BP, and both are equal. So it means it becomes the point A is becomes at the point B, and point B is becomes at the point P. So both are the joint, both are the closer to the point P. So that's why we can say this line becomes as a tangent. So that's why we can say differentiability, it means then the left hand differentiability is equal to the right hand differentiability. So we can write by this way LHD is equal to the RHD. After this, now you look at here, if a function f is derivable, then we can say then if a function is f is derivable at the point C, then it is a continuous function. It means if the function is derivable, so it means it should be a continuous function. So how to prove this one? You look at this. If we are taking the limit h tends to the 0, fc plus h minus fc, so multiply and divide by the h. So we can write this step, limit h tends to the 0, limit fc plus h minus fc upon h, and multiply by the h. If you are writing this, limit h tends to the 0, fc plus h minus fc upon h. So you can write this is represent the f dash c. After writing it, then we can write this is multiply with the h, and value of the h is becomes the 0 because it is already given limit h tends to the 0. So we get the limit h tends to the 0, fc plus h minus fc is equal to the 0. And then after writing it, then we can write separately limit h tends to the 0, fc plus h minus limit h tends to the 0, fc. Fc is represent the constant value. So after applying the limit, it does not give any effect to the function at the point c. So we can say limit h tends to the 0, fc plus h minus fc is equal to the 0. So now we can write limit h tends to the 0, fc plus h minus fc. So limit is already exists and this is equal to the fc. So function is becomes as a continuous function at the point c. So we can say if it has the differentiability, so at the point c, and then it we can say this is also a continuous function. Now, if we can write, but its converse is not true. It means I am saying if the function is a continuous function, so it may or may not be a differentiable function. So by this example, we can easily understand. If you look at this example, it is written fx is equal to the mod of x. So modulus of the x, you know the value of this, it either may be minus x or may be x. If it is minus x, so it means it is the less than 0. If it is more than, if it is x, so it means x value is more than or equal to the 0. So now this concept we have to apply to draw the graph. So first of all, if we are putting the value of the x is negative -1, -2, -3 and so on, so we can easily get the value of the function, and then we always get the positive value because it is given the modulus sign. Mod of -1 is the 1. Mod of -2 is the 2. So we have to draw the graph in the second quadrant. After drawing it, when if we took the value of the x is more than 0, so we can easily look at the graph. It becomes, the graph is lies in the first quadrant. So we can draw the graph only in the first and the second quadrant. After drawing it, then we have to look at the left hand differentiability and the right hand differentiability. For looking this, then you know the very well about the formula of the left hand differentiability. So apply the limit x tends to the c minus fx minus fc upon x minus c. So put the x is the 0 minus h, and then we get the limit h tends to the 0, f0 minus h minus f0 upon 0 minus h minus 0. And afterwards, we get the value. It is equal to the limit h upon minus h. If we are getting the limit h upon minus h, then after simplifying, we get the result is the -1. So left hand differentiability is equal to the -1. Now we need to find the right hand differentiability. In the right hand differentiability, we have to apply the formula limit x tends to the c plus fx minus fc upon x minus c, and after applying it, we can write limit h tends to the 0, f0 plus h minus f0 upon 0 plus h minus 0. And then simplify, we get the result limit h tends to the 0, h upon h. And then if you simplifying again, you will get the value of the right hand differentiability is equal to the 1. Now we can easily look at left hand differentiability is the -1 and right hand differentiability is equal to the 1. So -1 cannot be equal to the 1. So that's why we can say left hand differentiability is not equal to the right hand differentiability. At this point, then it means it is lies at the origin because we have to look at the point x is equal to the 0. So point is x is equal to the 0. So it means it should be lies at the origin where the x is 0. And then it means at this point it does not show the differentiability, and this point is a corner point. So that's why we can say if the graph is represented by the corner or sharp point, so it does not have the differentiability at the particular point. And again, we can easily understand by the another example. If we draw the another type of the graph, so in this graph, you can easily look at the tangent is the making the 90-degree angle with the x-axis. It means tangent is becomes the y-axis. So y-axis makes the 90-degree angle with the x-axis. So tangent has the angle 90-degree with the x-axis. So if you are finding the slope of this tangent, so it is equal to the tan 90 and it becomes the infinity. So that's why we can say if the curve has the vertical tangent and whose slope is infinite, so it is a it does not have a differentiability at the point particular point. So therefore it is written here, therefore function f is not differentiable at this particular point. So now we can easily understand about the differentiability and if it shows the differentiability and not showing the differentiability. So roughly we can speak then function f is differentiable and if its graph has no corner point and it does not have a sharp point, it or has a unique tangent with finite slope at any point on the curve. It means I am saying function f is differentiable if its graph has no corner or sharp point and has unique tangent with finite slope at any point on the curve. Now we can easily get the definition of the function also. So for a function f, derivable function is always belongs to the continuous function. It means all the derivable function is a continuous function, but all the continuous function cannot be a derivable function. It may or may not be a derivable function. Sometimes it may be a derivable function, sometimes it not be a derivable function. If it is not a continuous function, so it means it is not a differentiable function. Whenever we solve the question, we should be aware about this. Then function is a derivable, so it means it is a continuous function. And function is a continuous function, so it may or may not be a derivable function. If it is not a continuous, so not a derivable. So afterwards, we have to look at this. The definition, actual definition of the differentiability. In the actual definition of the differentiability, we can say a function is said to be differentiable at x is equal to the a if right hand differentiability and the left hand differentiability both exist and are equal. If these two are not equal, so function is not a differentiable at the point a. So that's why these two should be exist. It means it will be show the particular value and it should be equal to each other. Now we can easily write this left hand differentiability is equal to the right hand differentiability. So we can read also L f dash x is equal to the R f dash x. Afterwards, we have to read about the working rule. So in the working rule, we can write function is a differentiable at the point C if the left hand differentiability is equal to the right hand differentiability at the point C, where left hand differentiability and the right hand differentiability, you know the formula of it. So R f dash c is equal to the limit h tends to the 0 fc plus h minus fc upon h, and the left hand differentiability we can write limit h tends to the 0 fc minus h minus fc upon minus h. If both are the equal, so function is a differentiable. So whenever you solve the question based on the differentiability, so you should be keep this concept in the mind. That's why you will be able to understand, you will be able to solve the question based on the differentiability. So you know very well about the continuity and the differentiability also. In the continuity, I said then left hand limit is equal to the right hand limit, and this is also equal to the f way. That's why we can say function is a continuous function at x is equal to the a. And in the differentiability, I am saying left hand differentiability, it should be equal to the right hand differentiability at the point C. And you know very well about the right hand differentiability. It is equal to the limit s tends to the 0 f of the c plus h minus f of c upon h. And the left hand differentiability, it is limit s tends to the 0 f of c minus h minus f of c upon minus h. So by applying this concept, we can easily simplify the questions. Now look at this question. It is given, show that the function fx is equal to the x raised to power 4 by 3 is differentiable at x is 0 and hence find the f dash 0. First of all, we need to prove the differentiability, and then afterwards we have to find the value of the f dash 0. So write the left hand differentiability. Left hand differentiability, you know very well, it is denoted by the L f dash c, and this is equal to the limit h tends to the 0 f c minus h minus f of c upon minus h. The value of the c is because the 0, because we need to prove the differentiability at the point x is equal to the 0. So substitute the c is 0 here. So the formula becomes limit h tends to the 0 a function of 0 minus h minus f0 upon minus h. After writing it, then we have to put the value of the function. Value of the function, it is given the x is to power 4 by 3. So replace the x by the 0 minus h in the f of 0 minus h function, and replace the x by the 0 if you are writing the f0 value. So we can say limit h tends to the 0, 0 minus h whole power 4 by 3, and f0, it means replace the x by 0. So you have to write minus 0 raised to power 4 by 3, and whole term is divided by the minus h, and simplifying it, then you will get the result. So it becomes the limit h tends to the 0, h raised to power 4 by 3, because it is given the minus h whole power is the 4 by 3. 4 is given, so that's why the minus is becomes the positive. If the power is even, so that's why we can say it has the shows the positive value. So that's why replace the minus h raised to the power 4 by 3 by the h raised to power 4 by 3. After writing it, then h raised to power 4 by 3, power is the 4 by 3, so we have to apply the law of indices to get limit h tends to the 0, h raised to power 4 by 3 minus 1. If you simplify the 4 by 3 minus 1, you will get limit h tends to the 0 minus h raised to power 1 by 3, and substitute the value of the limit, then result is becomes the 0. So that's why we can say left hand differentiability is equal to the 0. Now we need to find the value of the right hand differentiability. In the right hand differentiability, we have to apply the formula r f dash c is equal to limit h tends to the 0 f c plus h minus f c upon h. And now replace the c by the 0, because we need to prove the differentiability at x is 0. So we get limit h tends to the 0 f c 0 plus h minus f0 upon h. You have to put the value of the function and replace the x by the 0 plus h into getting the value f0 plus h. If you are finding the value of the f0, so replace the x by the 0. Then we get the result limit h tends to the 0, 0 plus h whole power is the 4 by 3 minus 0 is to power 4 by 3 upon h. After simplifying it, we get limit h tends to the 0, h raised to power 4 by 3 pi h, and simplify one more time, then we get the limit h tends to the 0, h raised to power 1 by 3. Apply the limit, you will get the result is 0. Now we can easily look at the left hand differentiability is equal to the right hand differentiability, and both have the value is equal to the 0. So that's why we can say function is differentiable at x is equal to the 0. After writing it, we need to find the value of the f dash 0. So f dash 0, because left hand value and the right hand value both are equal to the 0. So we can say f dash 0 is also equal to the 0. So now we get the result of the f dash 0 also, and we have already proved the differentiability at x is equal to the 0. So this is the way to simplify the question. Now we look at this example. Show that the function fx mod of the x minus 1 plus mod of the x plus 1 for all x belongs to the real number is not differentiable at the points x is minus 1 and x is equal to the 1. In these 2 points, we have to find the differentiability. So first of all, we have to apply the modulus definition in the given function because the both the terms of the function it is given in the modulus form. So first of all, we have to look at what the value should be of the modulus when x is less than the minus 1. So look at this. If I am talking about the first term of the function, it is given the mod of x minus 1. So first of all, we have to apply the definition of the modulus here. So we can write minus of the x minus 1 and only positive value x minus 1. If the minus of the negative value of the given function, so it means we can say x minus 1 should be less than the 0. Simplify this inequality, then you will get the value of the x is less than the 1. After getting it, then we can say if the modulus of the x minus 1 is the x minus 1, so we can say x minus 1 should be more than or equal to the 0. So x is more than the 1. If you are applying this concept in the only in the first term, so you look it in the function fx, only first term you have to observe it. If it is the less than the minus 1, less than the minus 1, it means the value of the function of x minus 1, it should be equal to the minus x minus 1. So it is written here, this is the minus of the x minus 1. And now if we are talking about the value of the x is more than or equal to the minus 1 but less than the 1. More than or equal to the minus 1 but less than the 1. So again we can say less than the 1, it means the value of the function it should be equal to the minus x minus 1. So in this also written in the first term minus of the x minus 1. After writing it, then now you have to look it because we have to prove the differentiability at x is equal to the 1. So put the x is more than or equal to the 1. More than or equal to the 1. So first term is the mod of x minus 1. If we look this, then it has the value x minus 1 when x is more than or equal to the 1. So we can say first term is becomes the only x minus 1. After writing it, we have to observe the mod of x plus 1. It means second term. I am talking about the second term. So again, we have to apply the modulus definition here. If you apply the modulus definition of the function, so one value should be the negative, other should be the positive. So we can write minus of the function and plus of the function. Minus of the function value is the x plus 1. You write this x plus 1 and minus of the function when x is less than the 0. So that's why we can say x plus 1 is less than the 0. And simplify this inequality, you will get x is less than the minus 1. So now we can write the value of the mod of the x plus 1 is because the minus x plus 1 when x is less than the minus 1. When it is the positive value, then we can say when x plus 1 is more than or equal to the 0. When x is more than or equal to the minus 1. Now this concept we can easily apply to write the second term of the given function. So second term of the given function, now we have to look at only this second term. So if x is less than the minus 1, so function value is becomes the minus x plus 1. So write the second term here. After writing it, then you have to look at this. If the value of the x is more than or equal to the minus 1 but less than the 1, it means again it is written the value of the x mod of the x plus 1 is the x plus 1 when x is more than or equal to the minus 1. More than minus 1, it means here. Here is the more than or equal to the minus 1. So we have to write the value of the mod of x plus 1 is should be positive. So after writing it, then we have to look at the third one point. It is given that x is more than or equal to the 1. More than or equal to the 1, again we have to write the same value whatever we have written in the second term. So that's why so we can write x plus 1 here. Simplifying these all, we will get the value of the function. If we simplify the first expression, so we get the minus 2x when x is less than the minus 1. After this, if you are simplifying the second term, then you will get x is the 2, function value is the 2 when x is the more than or equal to the minus 1 but less than the 1. If you're simplifying the last term, so you can easily look at this is equal to the 2x when x is more than or equal to the 1. Now we can easily find the differentiability at x is equal to the minus 1. So right hand differentiability we find by applying the formula. We get limit s tends to the 0 function of minus 1 plus h minus f of minus 1. This divided by the h. So minus 1 plus h, it means it should be the more than the minus 1. More than the minus 1, it means if we look at the more than the minus 1, so value, middle value, it should be less. Middle value, this shows the 2. So value of the function of minus 1 plus h is becomes the 2. So we can write here the 2. And now if you are writing the value of the function of minus 1, it means it should be equal to the minus 1. Again, we have to look at the middle value. If the x is more than or equal to the minus 1, equal symbol is there. So that's why again we have to put this is as a 2. So 2 minus 2 upon h is becomes the 0. And we get the right hand differentiability at x is equal to the minus 1. Now we need to find the left hand differentiability at x is equal to the minus 1. So apply the formula limit h tends to the 0 f minus 1 minus h minus f minus h upon minus h. If you are applying this, so it means minus 1 minus h, it means the value should be the less than the minus 1. If it is the value should be less than the minus 1, we get the minus 2x. So we can write minus 2x and replace the x by the 1 minus 1 minus h. So minus 2 multiply with the minus 1 minus h, and then afterwards you have to write the value of the function minus 1. So value of the function at minus 1, we get this is also the equal to the 2 because x is more than or equal to the minus 1. So write this value is the 2. Simplifying these, then we get the result is the minus 2. And then afterwards we get the left hand differentiability is the minus 2. If you look both the differentiability, it means I am talking about the left hand differentiability. Left hand differentiability, so therefore, right hand differentiability at the value of x is minus 1, it is equal to the 0, and left hand differentiability at the x is minus 1, its value is minus 2. So both are the different values. So that's why we can say right hand differentiability is not equal to the left hand differentiability at x is equal to the minus 1. So therefore, f is not differentiable at x is equal to the minus 1. Now we have to check the differentiability at x is equal to the 1. So first of all, we need to apply the formula. Right hand differentiability at x is equal to the 1. So we can write this is equal to the limit h tends to the 0 function at 1 plus h minus f1 upon h. If I am writing the 1 plus h, it means we have to put the value of the function slightly more than the h. So that's why we can easily look it in the question. Then we get the function value is the 2x. So replace the x by the 1 plus h. Then we get 2 into 1 plus h. Now afterwards, we have to put the value of the function at x is equal to the 1. So we get this is equal to the 2. So after writing this value is as a 2, we get this is 2 into 1 plus h minus 2 upon h. Simplify this value and then apply the limit. This is equal to the 2. So we get right hand differentiability is equal to the 2. Now, similarly, we have to find the left hand differentiability at x is equal to the 1. So, we get limit h tends to the 0 the function at 1 minus h minus f1 upon minus h. So if we put the value of the function f at 1 minus h, so we get this is equal to the 2, and f1 is already 2, so we write there, so we get 2 minus 2 upon minus h. After simplifying and putting the limit, then we get the result is 0. So therefore we can say right hand differentiability is not equal to the left hand differentiability. So function is not differentiable at x is equal to the 1. Neither the function is differentiable at x is equal to the minus 1, and not differentiable at x is equal to the 1. That's it for today. Solve as many questions as you can to brush up the concept you have learned. Thank you.